Thanks for your time. My name is Kerk. I'm from Power Automation. So I have too many slides, so I will go a little bit fast. If there's anything, just fire it off, okay? So first of all, I think we all heard about what is smart city. So I'll just give a very high overview of how we see it. My background, Power Automation is actually part of the Singapore Power Utility Group. So we belong to utility. So we tend to be a lot energy focused. So when we started off, it was actually more to meet our need. And along the way, we realized there are other applications from surveillance, we support through partners. But I think what we want to demonstrate is that the potential of using white space can be from just metering to a lot more things that you can do. And all of them, I would say, falls into what we call a smart city application. So I will just talk about some of the challenges and some of the trials that actually are no longer trials. They are really converted to commercial deployments. So I think you heard about the business model and all this. I think we have also went that path, and we also find out how we can use it to support services. Okay, so we also share with you what we have done in the region. I think you talked about Fuxingzhen, which I think we did part of the work to show that the link can be done. And then we'll talk about what kind of projects we've done in the Philippines. And lastly, we also show you some of the products updates that we have and some comments that we hope that will be adopted here too. Okay? So to start, smart city. I think everybody talk about smart city everywhere. Everybody would not want to be caught without a smart city plan. So at the end of it, he's laughing. I agree. So at the end of it, what do we want? We want a high-speed communication to deliver services, to bring value, right? And it must be done at a lower cost. A lot of people tell, I want 100 megabits surveillance, 100 megabits, this, that. I say, are you ready to afford it? Are you ready to pay for it? So before we talk about high-speed connection, at least from where we're coming from, we talk about coverage, giving you some connectivity. If you go to a hotel, or you go to an airport, do you need 100 megabit or you just need to send a message down? Right? You just want the connectivity. So if you guys go to other places where it's more rural, you realize that having the connection is really precious, and it doesn't happen all the time. So from then on, you can deliver your services from healthcare, from M2M, from all the analytics we talk about. And from the grid, again, we are energy focused. We want to provide services to the consumer to tell them how much they use. You get your bill every month from the utility. Is it possible to deliver them through the network? And because utility, we are really selfish people. We don't like to share. We will lay a fiber to a substation 5 kilometers away, 10 kilometers away. That costs, I was just joking, one step, that's like a 600 US dollar to dig the road. And we will do it. Because why? Because all of you guys are paying for it. So we will dig fiber to collect 100 kbytes of data per day. And we do that all the time. So when it comes to white space and come to smart grid, we want to provide information through our own network. So how does this fall in together? Later we'll share with more. Okay. By the end of it, we want to give users options. We want to lower our costs. We want to make more offerings to our consumers. At the end of it, it's all about cost. Okay. Why are we here talking about TV white space? I mean, why can't you just put a LTE, put it to a lower frequency, and use it? Because you're not using it exclusively. And because of that, the cost of the license is almost free. And with that, it makes a lot of things possible. So it must be cost effective, and it must support open systems. How do you get other devices to come in? So people talk about shrinking them to devices. I say, yeah, that's a good plan. But there are many ways to interconnect down to other small metering devices, which we'll explore a little bit. So we want to give customers options, and we want to give them at a very cost-effective way. I keep stressing it because I think we got it. I would say I don't know how the rest of the world is doing, but we now have a big plan to cover the whole country. And I would say 3/4 of Singapore is really covered with white space. Okay. So challenges. I think consumers are expecting a lot. There are this cost I keep stressing, and then we have a lot of sensing devices. I think in Singapore, we're probably the biggest device user. Why? We have 3.5 million meters. We have 12,000 substations, and within each substation, we have hundreds of devices to collect data. So they add up together, we actually collect a lot of information, and how do you use the information? Then going forward, if you happen to go to Singapore, every 100 or 200 meters, you see a camera, and everywhere is under surveillance, because we care for the citizens, right? Yeah, you do. So eventually, I don't know how many cameras are there, but I heard from someone we have 200,000 cameras, so it's a lot of cameras. And so you don't want to run around naked in Singapore, man. We see you. So you remember the movie that, yeah. We see you all the time, man. So you feel safe. You're on the right side of the law. But if you're on the other side, you don't feel that well. So anyway, at the end, we need a common sensor network. So this is something I've been pushing. You see, we always believe that we want to have our own, but only be cost effective, we get it to share. So I think there are a lot of agencies everywhere. Everybody wants information. But if everybody set up a network just for your own, it costs a lot. So in order for this to succeed, we believe that somebody or one of the big agencies got to come in and say, now we'll build this infra, and how do we work with everyone? That's one of the key things that we want to do. So coming from power, we hope that, of course, we have the infra or somebody else has the infra where we can do it at a cost-effective way. Okay? So, and again, there are a lot of interest by many players to disrupt the market. I say, go ahead, we provide the services. So it used to be a dominant players where telcos come in and say, you can only buy connection from me. So how about other people coming in doing something else? Is it possible to be a mobile player using hotspots? So all these are questions that they all want to answer. From our point, how do we enable it? Okay, so these are the challenges. You want to be a smart city, somebody must take the lead. Okay, next. Sorry. Sorry. Okay. Okay. Anyway, okay, good. So we have two trials, one in Yuhua and one in Punggol. So these are the two places that we have actually deployed the network to provide services. So this is the actually design that we have. So from a base station, we bin it out to one of the buildings, and we have a mesh, or in fact, we have a multitude of other ways to connect to the devices. So we don't just use white space to end the device. We use broadband power line, we use Wi-Fi, we use Zigbee. So why don't we just go direct to the devices? The market is not ready yet, partly because I think everybody's struggling to make chipset to make it as cheap as possible. So there are a lot of low-cost device, low-cost ways to connect to them. And the amount of data they have is very little. So as much as everybody say, let's talk about devices, I say that would be the end vision. But in between now, how do I do it? So I put one connection to the building, and I use a Zigbee. The whole building is connected. So I can have multitude of devices from RF, Zigbee sensors, Zigbee motion sensors, tons of them, right? But do I need to develop them? No, I just provide connection to their box, and they're up, and they are part of my network. So that is how we actually got it deployed really fast, okay? So this is actually throughput map that we did for one of the towns. So you notice the base station is somewhere around here. Then we do a link test to everyone. So how many channels do we set up? 2 channels. So typically, every channel gets around 3.3 to 6 megabits. Sometimes you get line of sight, sometimes you don't get line of sight, So we have, when we first set it up, it was actually done for 38 blocks, now 158. Now we're going to, all the meters are being collected. So we use it to collect solar readings, how much solar being produced. We collect how much energy did the common services use, the lighting, the lifts, and all this. So all this information we collect, we send it back to the base station, which is one fiber, and then bring it back to a cloud. So once a reporter asked me, how is this cost effective? Well, there are around 200 blocks, and one fiber costs $300, $400. So you divide it out, I get around 10 megabits to each block, costing what, $1.50 per block. So that's cheap. So that's how when I charge them, I don't charge them cheap. No, I'm just joking. We still charge them, but not so much. And it becomes really, really cost effective to get it deployed. So we're not talking about dollars, we're talking about cents, less than $1 per point. So how many points are we talking about? So, and to prove that it works, what we did is that we even set up a Wi-Fi. If you look at this, somewhere around here, no line of sight, I'll show you the pictures, just to give you the Wi-Fi connection. So what we did is that we set up 4 channels, because it's for Wi-Fi, so you need higher throughput, so we aggregate them together to give you probably around 20 megabits. So at the end of it, what was the key message we deployed here? We set it up this in less than 4 months. So why? Because half the time, or 3/4 of the time, we set up getting the clearance to go to the rooftop. So we turn it on, you get it or you don't. So I was just joking in Oman when I did a presentation. The satellite company said in the first year you get 800 village, second year you get 1,000, third year you get 2,000 village. So when I went out, I said, let me show the same picture, 8 o'clock, 10 o'clock before lunch. I said, in a day. Why? Because you get a base station, you get it or you don't. Just power it up, you get a signal or you don't. So the deployment is really fast. This is one of the key things we realized. When you run an operation like us with thousands of sites or even millions of sites, how to deploy, how to manage it becomes a very important question. You see, you can't keep going back to manage it, okay? So you need to be robust. So this is other applications that we built. Some of them we go through partners. Again, we're energy related, so I have to qualify this. So now they want to do rooftop surveillance. They want to do car park surveillance. We love cameras because we like to see you on video, okay? Because we care about you, again. And we do a lot of people counting. We know, they keep laughing. So we count the number of people in the streets. We count the number of handphones there. So a lot of smart ideas coming up. So I even turned on my GPS 2 days back because I know Google's tracking, but I don't know what they do with the data. So people say, if you're so afraid, why don't you just turn it on? And I did, and it's really changing my life. I can't send my location. It's pissing me off. So anyway, so it's a balance, but it enables it to happen. So you have power counting, condition monitoring, living control. Now even the traffic police come in. They've been paying 3G, $100, $138 they just raised. So the telco loves this video surveillance. Oh, one camera, $138. Just count how many cameras that you need. So I had a tender recently. Any telcos here, guys? Yes. Oh yeah, okay, good. So we love them. So anyway, it's getting a little bit expensive because there are 200,000 cameras. So what we did was to try to lower the cost. Okay, so now we will talk about car park management. They always want to know where are the cars, how many lots there are. So have you ever went to a car park and asked yourself this question, where the hell is the car park lot? And why is it always full? So is it possible to know there are how many lots there in the car park before you arrive, and you can book it? So that question was asked by somebody. Then they start putting cameras and all this stuff. I say, how much it's going to cost you? So I say, why don't you just use my Wi-Fi and get it up? You know, just give me a free lot every time I come. That's fine. So I'm really liberal guy. So we set up the same thing in this place, base station here, and within this area, this quarter of the town. So we get 100 households, 100 blocks, 1,000 households. Again, one fiber. So that's cost effectiveness. Okay, so I think this is the message that we want to show here. So at the end of it, we even tell them it's a private network, so better security. Good. So next one. Yep. So these are the actual pictures from the town. The Yuhua town, we actually put the 4 channels here. This is a Wi-Fi hotspot. So this is actually a metal roof. And the direction is actually facing the wrong way. Why? Because I just want to show it's no line of sight. Just go the wrong way. Why? Anyway, 2 channels, if you notice. So we actually, sorry. So we aggregate the channels together. Again, we are obsessed with redundancy. Shit happens on one, shit happens again. If shit happens on the third one, it's act of God. We don't cover that. So, but I haven't reached that stage. It's all cost. So we put 2 channels to make sure we have full redundancy on that. So you notice they're not really very well placed. They just happen to be the most convenient place. Again, we are not running very high throughput applications. It's IoT. It's a lot of like metering services. We're not talking about 100 megabits. We're talking about 3, 5 megabits. You know? It's good enough for our application. So going forward, if you talk about maybe there will be more work to be done, then I agree. But what we did is to demonstrate that is this possible to get it up and get it up real fast. Okay, okay, next. So this is actually what we did in Gardens by the Bay. Very interesting project because they were the first user of white space for us. Because they came to us, they say, oh, we just commissioned this whole park. It cost of like $4 billion. And then somebody asked, where's the Wi-Fi? So can you imagine a hotel without Wi-Fi? Or a world-class facility without Wi-Fi? So somebody messed up. So when they built it, they forgot to put in Wi-Fi. So the guy, so they say, oh, that's no problem. Singapore, very efficient now. When we plan something, we'll dig up the park, we'll lay fiber, everything will be up $3 million in 8 months. Everybody go, what? You finished the park, you're going to re-dig it up again? So we came in. I said, I'll get it out in 4 weeks. You know, so, and I did. Why? Because I have to cater for 3 weeks to explain what I'm doing. So finally, I got approval after 3 weeks. Within a week, I set it up so I could give Wi-Fi coverage to the whole park. They could do more. They want we put out a camera to show the surveillance team that they could use it to see what's going on. Again, we love to see you. Okay, next. Yeah, so this is actually a proof of concept. The base station is over here. So we could cover the hotspot here, hotspot here, hotspot here. In fact, this CBD here, we actually put a receiving point. We got around 4 megabits to the CBD area. So we could provide free Wi-Fi to the CBD because it's just next door. Again, and it says that they were successful. It showed that it could cover greater distance without trenching. So again, speed of deployment, cost effectiveness. Okay, this is the Singapore Police Force. So people talk about surveillance. Again, it's not fantastic. It's again good enough for 1, 2, 3 cameras. More than that, maybe you got to do something about the bandwidth. But what we did is that we set up a base station somewhere around, let's say here. So the sites are here. And you notice they are all put on the street level. So again, the telcos, we love them, and they are really great guys, and they charge them $100, great too. But we came in and said, well, you can set up a local LAN because cameras don't serve internet. So the whole place was a LAN network. There was no 3G, no internet connection. So they set up, it was a hotel, they put the top floor, they put a base station, and they could set it up. You believe we set it up 28 cameras in a day? It's a day. Okay, so, and ongoing. In fact, Coast Guard, actually, another project, but they didn't agree to give me, that I released it, so I had to take out some information. But this is actually a test result that we did average. So you will notice the average speed, 0.5 megabits to 2 megabits or 3 megabits so per channel. Again, if they need more, we can add in a few more channels. So Singapore IDA is very supportive. They gave us a lot of spectrum, partly because we're near our neighbors, so certain bandwidth already been cordoned off. So we use those channels that set aside for Malaysia and Indonesia. So as of today, I think we're like 40 plus channels. So again, you will talk about one channel. Okay? If you want more, of course, it's hardware. Of course, if software compression from which we're using now, QPSK, you change it to OFDM, maybe the performance can at least be double easily. Okay? And this is based on 5 megahertz width, channel width. So LTE is 20 megahertz, so it's actually equivalent to 4 channels. So you take this speed, multiply by 4, convert it OFDM, the speed of this output, I think, triple, 4 times. So there are many ways you can enhance this further. So what we gain to prove that with the release of the spectrum, there are a lot of opportunities. So power grid, Singapore Power. So what do? We use it for a lot of stuff. So we have a lot of fiber, and we love redundancy. So we always make sure we have at least more than one pair of fiber. In fact, when we put in a fiber duct, it's 192 core. You know the big ones, the size of your head, we lay it all there. So fully redundant with many, many spares. But there's one problem. What's the problem? They're all in the same duct. So when you dig the road, I don't care how many pairs you have, they all go. So this is a problem that we have. And again, we have the best cable detectors around the world, but because it's operated by humans like us, shit happens, and we always messed it up. We dig it, it's gone. The whole station is gone. So happens all the time, okay? So I don't know about here, but cables are laid like 30, 50 years ago, and nobody knows where you are. Then the thing you do is supposed to be, but there's so many things down there, nobody knows what's there. So when we talk about redundancy, and today we talk about full redundancy, we want a full wireless network. And that's why I told you Three-Quarter Island is covered. This one is actually another agency, but on our own, we're also planning to roll out the whole country to have our own private network for metering, for substation control. Again, there's fiber. This is the redundant network itself. Okay? So we can, of course, I don't know about home payment. We actually focus a lot on that. Utility collects probably 80 to 100 million SGD a day. So they collect a lot of money. And a lot of transaction costs goes through us. We pay others. So one of the key things we wanted to do, at least on our own, we want to collect our bills at home. How do we let the guys pay at home? So one of the key things is how do we cut off the 5-6 million transaction costs that we pay every month? Okay. And then of course with this distributed generation, batteries, everybody, Tesla now wants to disrupt the market, put in battery. Every solar company will put on your roof. So they're trying to produce power themselves. So we also need to know how much they produce. So all this DG information we need to collect in real time. And then who's going to pay for the cost? So with this, the cost count goes lower again. So we could collect all this data at a fraction of the cost so we can encourage the deployment. If we tell them, oh, you got to do real time, you got to have availability of 99.99%, so they end up putting 2 or 3 lines, the cost just goes up. Okay? And our telco friends, whichever they are, will be very happy, but eventually adoption rate will go down. Okay. Okay, so this is where our smart homes come in. So we have a meter, though we want to put an app, and then we want to monitor the consumption, and we're coming up with a great scheme. So I don't know whether you heard about this thing called interruptible loads. So if you allow me to turn off your power, we pay you to be on standby. There is a market in Singapore for the utility. So we actually pay you to let us turn off your power. But we may not turn you off anytime we want, only when we need. Okay, so we pay you. Then how do we pay you and then yet pay for the running costs to keep the thing constantly connected? So you see the challenge here? So IL is a great idea. You know how IL works? You have a generator, and because you're scared the generator will fail, you put another generator, we call it spinning reserve. So they do nothing, stand by, waiting for the blackout to happen, and then the guy kicks in. When's the last blackout you've seen in Singapore? I don't even remember myself, you know. It's like, I've been in the company for 15 years. I can't remember when's the last blackout. So imagine I run all those generators, burning fuel, generating carbon and all that stuff for something that doesn't happen for 20 years. Maybe I can turn it off. No, they won't allow it, even though after 20 years we don't have a blackout. Why? I don't understand. So the theory is if we could find equivalent load out there who can allow us to turn off, maybe we can turn this guy off. So that's how the whole thing started. Then in order to do that, you need to have a high-speed network. Not just low speed, high speed, no longer little data, it's real-time data. Then we couldn't kick it off, and when white space appears, suddenly it becomes possible. Okay? Previously, it was only offered to big consumer. Now, every house consumer with a smart plug can do it. Okay? That's what we're building now. Okay, this is actually an actual deployment for a university where we actually use it to do a hostel. So we set it up, a base station. We didn't set up the backup because after a while we realized that it's actually quite stable. And we use the same standard for utility to go to the end consumer, but actually they are not willing to pay for that price. So we still have one base station. We have around 6,000 meters, and we cover the whole university, probably around 4.5 square kilometers with white space. And then now they are going to do the same trials. I don't know about, I think you guys, we have all been students before, so we always go and plug in your small little aircon we're not supposed to, your fridge you're not supposed to, so they actually charge you for the usage of electricity. So, but they always have to constantly enforce. So what we're going to do is we're going to put a smart plug, we're going to know exactly what is being used in each room. Okay, so this is one of the things we do. And then I don't know about the university, but some of the coverage for the Wi-Fi is not exactly as good. So what they do is that they buy the set, they do whatever they want. So they try to overlay. So they try to increase the coverage to the university. So this is another example. At the end of it, how much does it cost them? Maybe one-time equipment cost, but the fiber is still one. The whole campus is only using one fiber. Okay, so it was from the telco. Those telco are making money, so they are doing well, right? So we love them. I have to be careful, man. So anyway, this is what we did in Bohol. They wanted to cover schools, and then we said, okay, let's do it. So they actually gave us like 300 schools, 120 schools, sorry. So we set it up in what, 4 months? So again, speed of deployment. We put a base station, a fairway, and then the coverage is probably easily. So you see the endpoint here? Just a pole. So we set up a base station. We teach them how to set up in a day's training, and they could just set up, turn it on, you get it or you don't. If you get it, great. If you don't, call the police. Anyway, just joking. But it's really fast. As we do halfway through, there was disasters. They redeployed some of the sets to cover disaster area, getting schools linked up, getting the hospitals linked up. So again, ease of deployment. Once the base station is really fast. So this is my guy outside. He's there to help out. So the schools, hospitals using it. This guy, then one of the guy here is the governor of the town. So I was telling him, I'm sorry that you lost your house. He says, okay, I got many houses. I was like, most of us have one house. So it's quite bad. So it's some of the, you see, it's not clear, but you see, it's actually somewhere around here, the corner here. The little access point. So we get around 2.59 megabits. So from no speed, nothing to some, I think it's good. Like I say, coverage, 50, 100 megabit, great, lay a fiber, get faster, but be prepared to wait. So I was in India recently, and then the guy, new chief minister of a city, said, I want to have fiber to every town. I said, that's great, it's a great idea. I want every house to have fiber. That's great, sir. I think you have a great vision. How old are you, sir? He said, 69. I said, great, sir. We took probably 30 years to get the whole country well. I think another 1,000 years. You should be able to see it. So sometimes we have to be realistic. Huh? So next one. This is actually what he mentioned, so I'm just going to run through fast. So there was some long distance area to cover, and I think the fiber or the base station was somewhere. It was really far. So again, it's not cost effective to use other technologies because the cost of laying and the cost to maintain is going to be more than the cost to the subscribers who pay is not going to pay for this. So I think I'm going to skip this part. So this is what we did. So we did a testing on every channel, and then we took 4 hours to get this up. Why 4 hours? Because time is almost up. So because we took 3.5 hours to walk up the mountain. So we turn it on and you get it straight away. So that's key. So sorry, I'm just going to run through the fast one. So I'm going to skip all this because no time, but basically no line outside. And some of the pictures that we have, installation, see? So it was easy to install some of the antennas that we have, the base station, the end nodes, so the outdoor units that we have installed. And of course, everything comes at a price, so they have to pay us for this, so that's great. Again, okay, this is a module that we have, the metering module. We use it to connect other devices. It's small footprint, it's Wi-Fi ready. So I have this vision that every meter is a hotspot. So you pay me your electricity bill, I give you Wi-Fi. Because I realized that a lot of people rather have Wi-Fi than food. So that was this joke I was always saying in South Africa when I went. He said, okay, Kerk, you're always looking for Wi-Fi. Because I just want to send my message. He said, I give you a choice. I say, Kerk, if you eat or Wi-Fi, your lunch is here. I say, look, if I don't eat, I'll probably die in 4 days. If I don't have Wi-Fi, I'll probably die today. So that's it. I'm going to go for my Wi-Fi. So we all cannot live with Wi-Fi, okay? So at the end, we want to reduce the cost per unit. So there's ongoing development that we're going. So this is the last second or third slide. So we are here. So we're pushing for a 100 megabit set by aggregating 8 to 12 channels. And then we continue to do that. And of course, there are protocol compression changes that we believe will increase the speed too. So I think when we reach somewhere around here, we think we'll probably be ready for video surveillance. Again, not my call, but can be done. Okay, these are some of the pictures of industrial grade and commercial grade and offerings. So now we're going forward. So if you have a site, you want us to roll it out, and you have meters there, and I believe you have because you need energy, then we're willing to put it in for the metering. So little or no cost, because we love you, right? Okay, so these are the pictures. So what's over there? So he's over here. Yeah. So he got a lot of awards for this. Okay, so recommendations. Sorry, this one I need to mention because I think there are regulators here. So one of the key things that we got to encourage active sensing because we don't know how dirty the spectrum is, and it's important that we get information feedback. So this one piece we don't do, but we feel that it's really critical that it's covered so that we all know what is going on on the ground. And we should have a regulation that goes as a trial process. A lot of countries I go, everybody wants to get all the framework before they even allow us to start. Please don't do that. By the time you finish, my son is old enough to do something else. So please don't do that. Let us try, show you the results, give you the output, and then from there you see, you learn more, and you adjust accordingly. So that thing I must say, the Singapore IDA was very, very open about it. They actually regulate as they do the trial. So they don't stop you. They just say, go, but though with these terms, that's fine. Okay, yeah. So and then there are many devices. So I don't agree with all the standard and frameworks because some of them are pretty strict. How fast you make it. I have devices running on battery, so you can't get them to check your spectrum all the time. So these are some of my comments. And then the last one, HPC. You need to have this because without HPC, you assume that people will just use it because it's free. But we are willing to pay. We're willing to pay, but not all the time because we don't need it all the time. But when we pay, we get certain availability. We guarantee services, then we can use it for critical services too. And remember, if we pay, it's fine because end up you will be paying for it because we are just going to pass it down to you. And we're going to slap you my AirPod. So a lot of times the regulator will charge me 100 million. I say, why don't you put $1 billion? I don't care. But who's going to pay? You. You're going to pay. So have a way in between. Last slide. So we come from concept to commercialization. There's no need for so-called technical trials. Now it's commercial trial, developing the right business model to make it move and move it fast. Okay, so that's it. Sorry for the time exceeded. So thank you very much.